All right, so we are beginning the parametrics with the calculus now, finally. So literally the first two sections were simply pre-calc, actually, because it was just setting up how to graph parametric equations. So if I ask you, give me some terminology for derivatives. I heard dy dx. I heard slope of the tangent. The what? You mean just f prime of x for the terminology? F prime of x, y prime, all of those. This is Leibniz notation. Yeah, so if I needed to find the slope of a tangent line, I would be finding a derivative. Everybody agree? So I don't want you to just be given a formula for dy dx, because I hope that you'll be able to like see where it derives from. But if y equals some function of x and x equals some function of x, right? How do you think you would find dy over dx? I said these are functions of x. What are they really in parametrics? T or theta or something other than plain x, right? So these are functions of t or theta or something, some other parameter, right? How do you think you would be able to find dy over dx? Take the derivative of both and put them over top of each other. In other words, dy dt divided by dx dt. If we need a proof, what do we do with division? Flip it and make it multiplication, right? Look what happens to the dt's. Literally, there's our proof. So here is the formula for the derivative of parametric equations. In this instance, it would just be f prime of t over what? G prime of t. Everybody with me on the formula for the derivative? It is absolutely my favorite formula. So, I mean, in the BC stuff, because it's really straightforward and easy, isn't it? So let's say they just say find dy dx for x equals sine t and y equals cosine t. What's our formula? dt over dx dt. What is dy dt? In other words, the derivative of y with respect to what? T. What is dy dt? Negative sine t over cosine t. If we wanted to rename it, what could we call that? What is sine over cosine? Tangent. Any questions? Literally, the derivative of y. Now, can I tell you, we're just in chain rule with AB. And what happens is we get in, I'm saying chain rule, it's the actually U substitution or the integration with using the chain rule or reverse chain rule. And so we have to make sure the derivative of the blob is there and all that, right? Do y'all remember that? Well, so when they start taking derivatives again, then I go back to taking a regular integral. Guess what they do? They take derivatives of the integral. It's just, you know, it's difficult. So how could I make a problem like this more difficult? We started out with just derivatives. What was the first kind of application for derivative? Not just the slope of the tangent, but the equation of the tangent. Now, in an easy instance, they might say, we'll make this part B. Part A, find the equation of the tangent at t equals pi over 2. Oh, well, we're going to have a slope. I guess if I ask for the equation of the tangent line at t equals pi over 2, what is the tangent of pi over 2? It is undefined. Pi over 2 is where that asymptote is, right? So how do I write the equation of a line with an undefined slope? Any undefined slope. That is x equals some number, right? X equals some number. So how would I get that some number? Go up to the original. T equals pi over 2. What is the sine of pi over 2? 1. Sine function at pi over 2. It's up there at 1, right? So that's not beautiful, especially if it was undefined. But here I'm giving you a point which may seem nice and easy. I think I needed to do this. I'm sorry. It may seem nice and easy because I already give you the point. However, what have I not given you? Our formula has a what in it for the slope of the tangent. Yeah, I've given you the point. I haven't given you the slope. And the slope has a what in it? It has a t in it. I've not given you the t for this. Any ideas, any suggestions, please engage. How in the world could I find the t, Jack? Plug in a number. Plug in this for what? In an ordered pair, what always comes first? Plug in this for x. Anybody know what t gives me a sine of root 2 over 2? Sine stands for over hypotenuse. Opposite is root 2. Hypotenuse is 2. Is that ringing a bell? How many degrees? 45 degrees, which is pi over 4. That's one of them. I mean, obviously, it could be 3 pi over 4, right, in second quadrant. So now we have to come over here and plug in root 2 over 2 for the y value. And the cosine of an angle is root 2 over 2, adjacent over hypotenuse. it does give us that same t value of what? Pi over 4. Now we know what to plug in. dy dx at t equals pi over 4 is negative tangent of pi over 4. What is the tangent of pi over 4? I've drawn it out up here.
It's 1.
It's just 1, opposite over adjacent. So now we have a slope and we have the point. How do we turn it into an equation? Y minus y1 would be root 2 over 2 equals negative 1. Okay. X equals square root of t, y equals 1/4 t squared minus 4. Find dy dx. Oh no, find slope and concavity at the point 2, 3. All right, we can find slope. We've got our formula, right? We'll have to figure out what our t value is, but we have our formula, right? But what about concavity? That comes from what derivative? The second derivative. So now I'm going to have to give you the formula for the second derivative, right? The proof of this one to me is not so easy, but all we do, my gut would tell me, just take the derivative of the first derivative and be done, right? But that is not all. You take the derivative with respect to t of the first derivative, but then we have to divide it by another dx dt. In other words, this just means the derivative of the first derivative, right, that we already took, but we have to divide it by another dx dt. So what do you think the third derivative would be? Derivative of the second derivative, right? And we divide by another plain dx dt. So let's practice doing that. What is the square root of t really? How can we rewrite that? T to the 1/2. So what does dy dx equal to? If we want to think of this as 1/4 t squared minus 1, we could, couldn't we? Couldn't we rewrite y? And so then what is dy dt?
1/2 t squared. Oh wait, y first, sorry.
Oh yeah, the y. 2 times 1/4 is 1/2. T to the what power? First. Divided by 1/2 t to the negative 1/2 I just heard, right? What happens to the 1/2s? cancel. What is t to the first divided by t to the negative 1/2?
T to the 3/2.
Everybody see what he did with those powers? 1 minus a negative 1/2 is really adding a 1/2. So, so slope, we're well on our way. What about concavity in terms of formulas? What's the derivative of this? Not too bad. 3/2 x, t, sorry. Lower the power by 1 would be 1/2. But we just need to divide it by another dx dt, right? So what will that end up with? 3/2 divided by 1/2 is like flipping and multiplying by 2/1. Is that just 3? And t to the 1/2 on top divided by 3t. I like it. But they are all in terms of t, so we don't know yet what would I plug in for t to get 2 for x. Square root of 4 is 2. So let's check. Could t equal 4? What's 4 squared? 16. 16 minus 4 is 12. 12 times 1/4 is 3. So t does equal 4, right? And we all make those same mistakes every time. So what is the slope of the tangent at t equals 4? The square root of 4 cubed, because 2 cubed is 8. There's the slope of the tangent, and then the concavity is 3 times 4, 12. So it would be concave up, wouldn't it? Increasing, concave up at the 0.23. Does that make sense? The function would be increasing concave up.
How'd you get the square root of 4 to the third power?
Oh, 4 to the 3/2. The bottom is the square root, right? The top is the power. Thank you for asking that. How many of you also had that same question and refused to ask?
I was gonna ask how did you get the t equals 4 to plug in?
The first thing was, what would t be if x is 2? What do you do to solve for t? T equals 4. And then I simply checked to make sure that when I plugged it into the y, 4 squared was 16 minus 4 is 12, divided by 4 would be 3. And so it checked out for both the x and the y. Sometimes you'll solve and get like 2 possible t's or something, and you just have to figure out which one works for that one. Make sense? How about arc length? Somebody give me the first formula that we learned here in BC for arc length.
Square root.
Yep, integral a to b, square root,
1 minus
nope,
plus
close. 1 plus f prime of x quantity squared. There it is. So now I'm going to try to show you how this can morph into something with the dt's, right? So f prime of x is really dy over dx, right? And if I square it, would you say both of them would be squared? Okay. But in parametrics, dy dx is really dy dt, right? Squared over dx dt squared. Everybody agree with that statement? And I'll just ignore the limits of integration right now. So now, what do I do with what can I do in order to add two fractions together? Get a common denominator, which would be dx dt squared. So what are you seeing now? We have the common denominator, right? Can we just put it over 1? Everybody agree with that? What is the square root of something squared, though? Itself, right? So I actually could take out the bottom to be a plain dx dt. Would everybody agree? Now I'm dividing by a fraction. What can that become? Multiplying by the flip. Well, look what happens. dx's are gone. And what am I left with? A dt. This is the arc length formula. For parametrics. Bless you. So, if I just give you x equals t squared, y equals 2t, and I want to have the arc length on the interval from 0 to 2. This 0 to 2, these limits of integration are t values. That's the only thing that I have trouble. Like this a and b are x values, aren't they? So those would have to be converted to t values, whatever they are. So what's our setup for arc length? Integral from, it's given, 0 to 2. Big square root of x prime, or x dx dt is what? Quantity squared. What's the derivative of y with respect to t? What will this be? Four t squared plus 4. And I'm telling you, many, many, many times, this cannot be done by hand. I can't think of any of our tricks that we could make, that we could get that integration by hand. Can you? I mean, integration by parts, you know, but it's gonna cause issues. So I will tell you many, many times these are on calculator problems. But this one had no calculator problem. It had no picture of a calculator. So I'm just wondering how in the world they were wanting us to do this by hand. You can't get it out of the square root.
You can't put it to like 1/2 or something.
I mean, I could get out a square root of 4. I could do it like this. But you're missing a t, right?
Or you made it negative somehow on the inside. Yeah, really throwing a negative out of nowhere.
I'm trying to think of like geometry. Is there a geometry formula that we could? I don't think so. Oh, maybe. If I said y equals t squared plus 1, I'm sorry, the square root of that, what would y squared equal? Oh no, that's just going to be y squared minus t squared. That's going to be a hyperbola. I don't have any hyperbola formulas, do I? I got nothing to do this by hand. Many, many times. These, especially parametric. Didn't it happen with our arc length before too? There were many problems that literally you just had to do them on the calculator. 0 to 2 square root 4t squared. Nobody's come up with a way to. By the way, why did the calculator give me t's? I'm in parametric, right? So 5.916. Knowing the slope of the tangent is dy dx. And I ask you, where do we have a horizontal tangent and where do we have a vertical tangent? Horizontal would be on the maxes and mins, exactly. So in other words, you could use that to find some maximum and minimum points, right? What is the slope of a horizontal line? 0. What makes this 0? The top 0. dy dt equals 0, while dx dt is not 0, correct? Because 0 over 0 might not be horizontal, right? What would make a vertical tangent? Loud and proud. You started to say it. When the bottom is 0, right? The bottom of a fraction 0 makes the fraction undefined, right? A vertical tangent has an undefined slope. We'll add in those little, while dy dt is not 0. So if I ask you to find all points where we have horizontal and vertical tangents, Could you do it? I'll do 2 more examples and then stop. I mean, this example and one other. So what are we looking for? Vertical tangents. I'm sorry, horizontal tangents.
Where dy over dt versus
dy dt equals what? 3t squared minus 3? Where does that equal 0? 1 and negative 1, right? Now, we do want to make sure, yeah. We do want to make sure that dx dt is not 0 at the same time, right? 1 minus 1 is 0 plus 2, 1 is okay. Negative 1 squared is 1. Minus a negative 1 would be plus 2. That'd be 4. So both of those will work out, right? And, oh, but they did ask for points, not for t values. How do I turn it into a point? Plug it in. Oh, I just plugged it in. 2 for the x, right? Plug in 1 for the y. 1 minus 3 is negative 2. And the second point was, the x value is 4, wasn't it? 1 plus 1 plus 2. Negative 1 minus a negative would be plus. Negative 1 plus 3 is 2. So those are the places where we have a horizontal tangent. How about a vertical tangent? What's dx dt? Minus 1. 2t equals 1 when t equals. So only one place where we have a vertical tangent, right? 1/2 squared is 1/4 minus 1/2 plus 2. 2 minus 1/4, 1 3/4. 7/4. And the y value would be 1/2 cubed, 1/8 minus 3 times 1/2, 3/2. Is that times 4? 1 minus 12 would be negative 11/8. Now, the other one is if it has trig in it. That's when it becomes a little dicey. Same thing, horizontal and vertical tangents. Let's go for cosine squared theta, and y is 2 sine theta. So we are looking for horizontal, vertical. Probably should have done them backwards because the vertical comes from this one being 0, right? Or the d. But what is dy dt equal to? 2 cosine theta. Where does cosine theta equal 0? Pi over 2. Where else? 3 pi over 2. Negative pi over 2. I don't like them not giving us a. But we may find some points that keep showing up. It is vertical when the dx dt equals 0, right? What is dx dt? Power down in front would make it 8. Leave the cosine alone, right? Times the derivative of cosine would be negative sine. Negative. All right, and that equals 0. Uh-oh. At all the same places that this one equals 0? And all the other places where sine equals 0. What is that? 0, pi, negative pi. If I said dy dx 2 cosine theta over negative 8 cosine theta sine theta, I got negative 1 over 4 sine theta. So we would not have any horizontal ones, would we? Does everybody agree with that? Because if I canceled out the cosines, they're gone, and we would really only be worried about vertical tangents. At if t theta equals where theta equals 0, what is the cosine of 0? 1 times squared is still 1 times 4. The sine of 0 is 0. At pi, the cosine is negative 1, correct? Squared is still 1, so that would be 4. And the sine is still 0. All of these are going to be the same points. We literally have 1 point. And let's check. Let's graph that thing. For cosine square. All right. Does this make sense that we're not going to have any horizontal tangent lines? Let me go ahead and watch it graph. I'm going to go ahead and I'm going to go like negative 3 pi to positive 3 pi, just so we can see what the particle is actually doing. That way, it just keeps bouncing back and forth. But every time it hits the point, what? 4, 0, it has a vertical tangent line, and there are no horizontal ones. So, what did you say?
That's pretty cool.
I think it is. All right. So let's just get you going on page 727. We did equations of tangent lines, right? 5 through 17. And then 29 through 37.